vertical stresses in soil. So for our lesson that we will discuss on this meeting, pag-usapan natin yung vertical stresses sa ating soil o sa ating location. Okay, but before that, for our information, soils experiences different kinds of stresses. It can be vertical stresses, it can be lateral earth stresses due to yun nga, loads vertically due to lateral pressure. Okay? So, as a basic formula sa ating stresses, alam naman natin that stress is force over area. Meaning to say, kapag malaki yung loads na pinapakarga natin sa ating medium or yung ating soil in particular, at kung maliit yung kanyang area, definitely yung stress natin is malaki yung kanyang intensity. Okay? And vice versa, kapag malaki yung loads at kung malaki naman ang inyong area, definitely magkakaroon tayo ng maliit na stress or maliit na value ng pressure. Okay? On the other hand, if maliit naman yung loads na pinapakarga natin and malaki yung kanyang area, definitely still makakakuha tayo ng stress na maliit yung value. So, kailangan merong inversely or proportionality yung relationship ng forces and area with regards sa ating stress na i-compute or may experience. Okay? So nabanggit ko nga kanina that soil itself experience different kinds of stresses. Okay? To analyze these problems such as yung pag-compress or compressibility ng ating soil, bearing capacity ng ating foundation or yung kanyang resistance to load applied sa ating soil, yung sa ating excavation, stability of embankments, lateral earth pressure sa mga earth retaining structures natin, katulad ng mga bearing walls, sheet piles, etc. So kailangan tayo mga engineers, alam natin kung paano ba nagbe-behave or nagdi-distribute yung mga stresses along a cross-section or soil profile natin. So ayun, dapat alam natin yung behavior ng mga stresses. So the issue is referred to as effective stress and is discussed on this topic or this chapter. So una natin pag-usapan is the vertical stresses. So napag-usapan natin that in relation sa ating mga previous subjects such as in hydraulics, kapag lumalalim yung ating embedment or kung toro lumalalim tayo in terms of depth, mas lumalaki yung stresses na nai-induce ng ating soil or ng ating media. Okay? So mapatubig yan, mapasoil, or whatsoever. Kung toro lumalalim siya is lumalaki yung stresses natin. Okay? So this particular topic sa vertical stresses, so pag-usapan natin yung total vertical stresses, kung ilan ba yung summation without the necessary elimination of such stresses. Kumbaga yung kabuuan na nasa-stress o kabuang stress na nakukuha ng ating soil. And it is related to the different kinds of unit weights, mapa dried, mapa moist, or saturated itself. So meron yan lahat connection with regards sa total vertical stress. And napag-usapan din sa hydraulics that stresses can be computed based on the unit weight multiplied by its height or in terms of unit of measurement. So magiging unit natin dito, it can be kilopascal, megapascal, kips, or etc. Basta unit of force over area. Kasi kapag kinompute natin to, let's say for example, unit weight natin is in terms of kilonewtons per cubic meter. Multiplied mo yan ng meter. So makakancel yung isa, makititira is kilonewton over meter squared, or newton over meter squared is pascal. Okay, so in short, stresses, kapag ganito yung mga units natin, referred to as a kilopascal. Okay, so yun yung mga unit of stresses natin na kailangan natin i-take into consideration. Okay, next, pore water pressure. Ito naman, pore water pressure as it name suggests, ano ba yung epekto ng tubig sa ating cross-section ng soil. So napag-usapan natin that kapag malapit yung point natin sa water table, humihina or bumababa yung ating stress or pressure. Okay? Other term ng pore water pressure is the neutral stresses. So ito naman, since tubig yung pinag-usapan natin dito, yung unit weight of water yung consider natin dito. And depende din yan sa kanyang height or depth. Okay? Last, the effective stress. Pag sabi natin effective stress, ito yung difference ng total vertical stress at saka ng pore water pressure. So yung effective stress is the difference between the total vertical stress and the water pressure or the neutral stress. So by the way, the total vertical stress, yung symbol niya is, so may subscription na T represents the totals, stress total. And water pressure, symbol, this symbol, and W represents water, or sa ibang mga references, U yung kanyang symbol na ginagamit. Next, effective stress is this symbol, tapos meron siyang hyphen or parang prime, kumbaga, or sa ibang references, meron siyang word na effective to represents the effectivity stress. So going back to the previous definition of the effective stress is the difference between the total vertical stress minus the pore water pressure. So that is its equation. So anyway, that is the sum of the stresses na pag-usapan natin dito with regard sa vertical stresses sa ating soil. Okay? Total vertical stress, or this symbol and T represents, so pwede siyang kilopascal, megapascal, pounds per square foot, pounds per square inches, or etc. So basta unit of force over area. So total vertical stress can be computed using the unit weight 1 multiplied by the H1 plus unit weight 2 H2 add to the nth term of the unit weight as well as the height at the nth term. So kumbaga wala pa tayong binabawas na unit weights dito, kabuuan. Okay. Next, pore water pressure. So magdedepende lang yan sa kung saan ba located yung ating water table. And i-multiply lang natin yung kanyang depth based sa kanyang unit weight of water. So meron tayong constant unit weight of water na 9.81 kilonewtons per cubic meter. Meron naman sa English na 62.4 pounds per cubic foot, so etc. So, kailangan kabisado natin yung mga different kinds of constants, lalo na sa unit weight of water natin. Last, effective stress. Sabi nga kanina that effective stress is the difference between the total vertical stress and the pore water pressure or the neutral stress. So, those are the equations or the formula na pag-uusapan natin, gagamitin natin sa pag-compute ng mga vertical stresses sa ating soil sample. Okay? So, yung mga stresses natin or mga unit weights natin, lalo na kung nasa taas siya ng water table, tinitreat natin yan as a dried unit weights. Okay, kahit napag-usapan natin na yung in situ or natural condition ng ating soil are moist, with respect sa ating vertical stresses determination, tinitreat natin yung mga soil na in above sa ating water table as dried. Okay? Dried yung unit weights natin. However, merong instances na nagkakaroon ng capillary action or yung bibig sabihin ng capillary is pagtaas or pagsipsip pataas ng tubig natin papunta sa taas. Okay? The effects of capillary rise in soil water rises and variation in degree of saturation with the height of the column. So pag sinabi natin na capillary rise, umaakyat. Diba, meron tayong soil sample dito. Ito yung capillary umaakyat pataas ng ating tubig. Kumbaga nag-evaporate, kumbaga mas layman's term. Okay? That is the capillary action sa soil. So, to thoroughly define what is a capillary action, so capillary action, na-discuss naman natin sa mga fluid mechanics subjects or hydraulics. Halimbawa, meron tayong test tube dito. Ito yung ating water table or yung ating water. So, yung water natin, due to the some events, nagkakaroon yan ng capillary or umaakyat pataas. Capillary action. So, meron din yan effect sa ating soil stresses. Okay? So, syempre, tubig lang yan at siya degree of saturation. So, magiging concern lang natin is hanggang saan ba yung height na merong capillary action. So, meron tayong equation dito na magde-determine kung gaano ba kalalim or gaano ba yung in terms of length yung ating capillary action. So, meron tayong equation na C, which is a constant na usually given naman yan, void ratio, and this one is the diameter at 10% finer. So, lahat naman is kabisado na natin yan. So, ngayon, if meron naman niya given na height na merong capillary action, there's no need to compute or to solve the height of the capillary action kasi meron na siyang binigay na height. Okay? Ano naman connect ng or ano naman yung gagawin natin kapag mayroong capillary action? Sa effective stress distribution, ima-minus natin yung effect ng capillary action. So by this equation, the S represents the degree of saturation. YW or gamma W is the unit weight of water. And HM is yung height na may capillary action. Okay? So, yun yung mga tatandaan natin na equation. Okay? So, effective stresses, total for water pressure, and the effects of capillary action. Okay? So, to better understand the concept of the vertical stresses, mag-solve tayo ng mga problems. So this problem came from a CE board exam last November 1998. A clay layer of a 4-meter thick rests beneath a soil deposit of a submerged sand 8 meters thick. The top of the sand is located 3 meters below the subsurface of the lake. The saturated unit weight of the sand is 25 kilonewtons per cubic meter and the clay 20 kilonewtons per cubic meter. Determine the vertical pressure or the total vertical pressure, pore water pressure, and effective stress at the mid-height of the clay. So, para madali yung pag-solve natin dito, kailangan i-drawing natin kung ano ba yung kung saan ba yung kung ano ba yung itsura na nating soil profile. Okay? So, i-drawing natin. So, sabi niya, a clay layer is 4 meters thick. Rests beneath a soil deposits of a submerged sand. So, ibig sabihin, yung clay daw natin is nasa ilalim siya ng 8 meter thick na sand. So, assuming meron tayong okay. Ito yung clay natin. At sabi niya, ito ay 4 meter thick. Ito daw yung kanyang lalim, 4 meters. Submerge and rest beneath a soil deposit's submerged sand. So 8 meters thick. Meter thick. Ito yung ating sand. Hangin. The top of the sand is located 3 meter below the surface of the lake. So, meron pa daw layer dito na 3 meters. Ano yung 3 meters na yon? Sabi niya, the top of the sand is located 3 meter below the surface of the lake. So, yung lake natin, so yung layer na to na 3 meter is H2O or water. So, nandito daw yung ating water table. And nabanggit naman dito that a soil deposit is submerged. Ibig sabihin nakalubog daw yung buhangin. So, yan. So, 3 meters na lalim ng tubig, 8 meters na lalim ng sand, and 4 meters na lalim ng clay. So, this is the cross-section ng ating problem. Next, the saturated unit weight of the sand, and nabanggit na naman dito saturated unit weight. Ibig sabihin, totoo nga na fully submerged na yung ating sand. So yung kanyang saturated unit weight is 25 kilonewtons per cubic meter. And a clay na 20 kilonewtons per cubic meter. Determine the total vertical pressure for water pressure. So, pinapatanong yung total water tsaka effective at the mid-height of the clay. So, ibig sabihin, hanggang dito lang. So, denote natin as point A. So, dito daw, point A. Or kalahati ng 4 ay 2 meters. So, mid-height of the clay. So, sa mga following lessons, yung effective stress at the mid-height of the clay, tinatawag din natin yan na PO or overburden pressure. Pag sinabi natin overburden pressure sa mga succeeding topics, automatically that is the effective stress at the mid-height of the clay. So ito yung one unique na tawag sa effective stress at the mid-height of the clay. Sa mga settlements, makikita nyo yan. Okay? So before that, dito muna tayo sa lesson natin or dito sa topic. Okay? Hanapin daw natin yung total vertical stress. So, umpisa tayo dito sa taas, papunta sa point na ito. So, 9.81 for the water dito, multiplied by 3 meters, plus, dito naman, saturated, dahil wala pa tayong babawasan or total yung hinahanap, wala pa tayong iba-minus na quantity. So, 25 multiplied by 8 meters plus hanggang dito 20 kilonewtons multiplied by 2 dahil mid-height of the clay lang yung pinapahanap. So kapag kinompute natin yan, makakakuha tayo ng sagot na 269.43 kilo Pascal. Isi natin. Nakakuha tayo ng 269.43 kilo Pascal. So ito yung sagot natin for question letter A. Question letter B, what will be the pore water pressure? So ano daw yung pressure na na-induce ng tubig? So to solve that, pore water pressure or neutral stress is 9.81 for the unit weight of water and mid-height of the clay hanggang dito. Tama. Ito yung may tubig. So 3 plus 8 is 11 plus 2. This will is also 13 meter. So 9.81 times 13. Makakukuha tayo ng 127.53 kilopascal. Ito daw yung stress na na-induce ng water pressure. Last, what will be the effective stress? So effective stress is the difference between the total minus pore water pressure. So 269.43 minus 127.53, makakukuha tayo ng sagot na 141.90 kilo Pascal. So ganun lang mag-solve ng vertical stresses sa soil sample. So magiging catch lang natin is saan ba located yung water table. Pangalawa, most of the time is hindi or kailangan pang i-compute yung mga unit weight. So kailangan kabisado nyo pa rin yung mga unit weight formulas, yung moist, sand, moist, dried at saka saturated unit weight formula. So doon lang naman iikot yung problem regarding sa pore water or total vertical stresses. So total, wala pa tayong mina-minus na any stresses. Pore water pressure, related lahat yan sa tubig. And most of the time is hindi ito given, so kailangan kabisado na. Lastly, effective stress is the difference between the total and the pore water pressure or the neutral stresses. So that is problem number 4.1, which is a CE board exam last 1998. Again, key points sa problem nito, another information, kapag sinabi natin na effective stress at the mid-height of the clay, automatically that is overburden pressure. Okay, next. Problem number 9.1, a soil profile shown in figure 9.3, calculate the stresses or the total stresses for water pressure and the effective stress at point A, B, and C. So pinapahanap niya yung effective stresses sa point A, ito, point B, and point C. So meron siyang given na properties, dried sand, 16.5 kilonewton per cubic meter. So located yung groundwater natin 6 meters above the surface. And meron tayong saturated sand na 19.25 kilonewton per cubic meter. So nakapatong siya sa clay layer. So first letter, what will be the total stress at A? So, since nandito pa tayo, wala pa tayong experience na stress. Nasa surface pa tayo. So, effective stress at A for water pressure at A and the effective stress at A is 0. Wala pa tayong pressure na nararamdaman at this point. Okay? Letter B, palitin ko yung kulay. What will be the total stress at B? So, pag sabi natin total, wala pa tayong minus. So, we have 16.5 times 6 meters. So, makakompute natin yan, 16.5 multiplied by 6. Makakukuha tayo ng 99 kilonewton per meter squared or 99 kilopascal. Total pressure or water pressure or the neutral stress, since wala pa tayong tubig dito, that is 0 kilopascal. And the effective stress is the difference with the total and for water pressure, we have 99 minus 0, we have 99 kilopascal. That is for point B, nandito pa. Kasi dito pa lang yung groundwater day. So since wala siyang binigay na properties at saka wala siyang in-indicate na capillary reaction, there's no need to compute the capillary ng sample natin. So okay pa tayo dito. Last letter C. What will be the total stress at point C dito? So 16.5 multiplied by 6 for this layer, pababa, plus saturated 19.25 multiplied by 13. So 16.5 for this layer, bababa pa tayo ng 13 meters na merong 19.25 na unit weight. Kapag kinompute natin yan, makakakuha tayo ng 349.25 kilopascal. Next, what will be the pore water pressure at point C? So, yung level of water natin dito, since wala tayo dito, there's no need to consider this depth kasi wala dito yung water table, nandito siya. So we have 9.81 para sa kanyang unit weight multiplied by yung kanyang entire depth na 13 meters. So yung pore water pressure natin, makakakuha tayo ng 127.53 kilo Pascal. Last, effective stress, meron tayong difference between the total stress minus the pore water pressure. So, meron tayong 349.25 minus 127.53 total effective stress at point C. So, okay lang naman na mayroon tayong subscripts dito to indicate the point. Okay lang. So, 349.25 minus 127.53, makakakuha tayo ng 221.72 kilo Pascal. So, makikita natin by the effect of water, nabawasan yung pressure or stress natin. Okay, so merong factor talaga or merong effect talaga yung location ng ating water table or groundwater table. So, ganyan lang resolve yung mga problems in relation sa vertical stresses. Next, to thoroughly mas malaman pa natin or maintindihan yung vertical stresses, mag-solve pa tayo ng problem. Third problem, for a given soil profile, compute the following. Total stress at point A. So, nandito yung point A. Medyo malabog lang. Compute the value of age, ito, kasi meron tayong piezometer dito. Piezometer. Effective stress if yung kanyang effective stress at A or effective stress at A ay 81.60 kilo Pascal. Let us see what will be the effective stress at point B. So, ito yung point B natin. So, total stress at point A. So, total. So, total stress ay meron tayong given na sandy clay, 20.11 kilonewtons per cubic meter. So, it is 5 meter depth. And yung groundwater natin is located 5 meters from the surface. So, nandito yung ating water table. So, meron tayong medium dense sand na meron siyang saturated unit weight, 19.03 kilonewtons per cubic meter. And dito, between the layer medium sand and the silt clay, meron tayong nilagay dyan na piezometer. Next, meron tayong 20 meter thick or depth na compressibly silt clay na meron siyang submerged unit weight na 11.97. Mamaya, pag-usapan natin ano ba yung submerged unit weight. Okay? So before that, compute muna natin yung letter A. What will be the total stress at point A? So, 20.11 multiplied by yung kanyang depth na 5 meters plus yung dense sand natin na 19.03, meron din yung depth na 5 meters. So, yung ating total vertical stress at point A, kapag kinompute natin yan, makakakuha tayo ng 195.70 kilo Pascal. Letter B, find the value of H, so pinapahanap niyo yung H na to, if the effective stress is 81.60. Kung ang effective stress daw natin at point A is 81.60, what will be the H? So, 81.60 kilonewtons per meter squared, equal natin yan dito, yung total, di ba? Ito yung total, 195.70 kilonewtons per meter squared. Minus, bawasan natin yan kasi nagbaba tayo, since umakyat ulit tayo, therefore negative yung gagamitin natin. Sa 9.81, bakit 9.81? Dahil ito ay tubig or H2O. 9.81 multiplied by height. So, one equation, one unknown, makakompute na natin yung value ni H. Kapag kinompute natin yan, makakakuha tayo ng height ng piezometer na 11.63 meters. That is the height ng ating piezometer, 11.63 meters. Last, letter C. What is the effective stress at what will be the effective stress at point B? So, ito yung point B natin. Located siya sa 30 meters below ng ating surface. So, meron tayong total effective stress dito, since meron siyang in-indicate. So, 81.60, baga dadagdagan na lang natin to ng difference ng unit weight of water at saka ng unit weight of saturated. However, binigay niya dito is submerged. Diba? So, kapag marami ka nang na-solve na unit effective stress, commonly, pinagsasama mo na lang yung saturated at saka unit weight sa computation. So, parang ganito, saturated minus unit weight of water. So, parang ganito lang. Tapos, multiply mo siya kunwari ng height. Okay? Kapag sinimplify mo kasing equation, parang ganito yung lilitaw. However, yung difference between ng saturated at saka yung unit weight of water is yung tinatawag natin na submerged unit weight. So the difference between the saturated and the water is submerged unit weight. And meron din siyang separate equation na GS minus 1 unit weight of water over 1 plus E. So meron siyang separate equation. So ulitin ko dito. Submerged is GS minus 1 unit weight of water over 1 plus E. Okay, kaso, this problem, given agad yung submerge. So, multiply na lang natin yan ng kanyang height. 81.6 plus, kasi pababa tayo, 11.97 multiplied by height ng 20 meters. Yung ating submerge or what is effective stress at point B, kapag kinompute natin yan, makakakuha tayo ng 321 kilo Pascal. Ganyan, i-compute yung problem na ito. So, one thing na magiging catch lang sa atin is kung ano bang unit weights yung binigay. Let's say, for example, binigay dito is dried dahil total. Dito naman is saturated dahil lubog na siya sa groundwater table. And dito naman, binigay na agad yung submerge. So, kailangan maging aware tayo dun sa mga units or mga given sa ating problem. Okay? That is for this problem. So, for our last problem, a soil profile is shown in the figure. So, meron tayong figure dito. Given age 1 natin or yung height 1 natin is 6 feet. Height 2 is 3 feet. Kumbaga, nandito yung capillary zone natin. Nag-rise pataas yung ating tubig. Ito yung ating capillary zone. Yung ating H1 pala or first layer is meron siyang 2.65 na specific gravity, meron siyang 0.5 na void ratio. Yung capillary zone naman natin or capillary rise, 2.65 yung kanyang specific gravity and 0.5 din yung kanyang void ratio. Yung kanyang degree of saturation is 50%. And after that layer, located na yun yung ating groundwater table. And one thing na very unique sa kanya, yung groundwater table or yung capillary rise is before natin makikita yung groundwater table. So hindi pwedeng nandito yung capillary rise tapos dito hydrate tapos dito is saturated. Hindi. Always sa taas ng groundwater table, if meron mang capillary action, yun yung capillary rise natin. Okay? Magkadikit si capillary rise or capillary action sa ating groundwater table. Always. Okay? Next, meron tayong layer ng clay. Meron siyang moisture content na 42% and specific gravity na 2.71. Tapos, meron tayong thickness dito na 6 feet din. Okay? So, ano pa yung pwede natin ma-derive dito na properties? Since ito ay submerged, ito ay saturated, definitely, yung kanyang degree of saturation is 100% or 1.0. Matik yan. Basta nasa ilalim na siya ng tubig. 100% or 1.0. Question. Determine the effective stress at point B. Ano daw yung effective stress dito? Letter B, determine the effective stress at point C. Determine the effective stress at point D. Okay? Tapos, dito, sa sand natin, meron lang siyang binigay na specific gravity. So, kailangan pa natin na-compute yung kanyang unit weight. So, to do that, dried unit weight is GS, unit weight of water, over 1 plus E. So, 2.65 multiplied by since naka-fit tayo dito, mas maganda siguro kung gamitin natin yung English na 62.4 pounds per cubic feet over 1 plus 0.5 na void ratio. So yung dried natin ay kapag kinumpit natin yan, makakakuha tayo ng 110.24 pounds per cubic foot. That is the dried. Okay, next, capillary zone. So sa capillary zone, di ba sabi natin kanina that any types of soil na aparte sa submerged is treated yan as dried. Okay? However, kapag meron tayong capillary action or capillary zone, parang nag-evaporate nga yung tubig natin dito pataas. So therefore, tinitreat natin yung capillary zone as a moist section or moist unit weight. Okay? So meron tayong moist unit weight na GS. Medyo ano sa mata. Black. Moist unit weight is GS, unit weight of water, 1 plus W over 1 plus P. Okay? So, since wala tayong given na W, pwede natin yan na-compute using sewage formula. SEWGS. So, divide both sides by GS. Cancel, cancel. So, makakuha na ngayon natin si moisture content. So, for the simplicity ng ating equation, i-derive na or diretso na natin siya. GS 2.65. 62.4 para sa kanyang unit weight of water. 1 plus W natin is SEGS 0.5 sa kanyang degree of saturation, 0.5 din sa kanyang void ratio, and 2.65 naman para sa kanyang specific gravity. So, yan. So, di-divide pa natin yan na kanyang total net na 1 plus 0.5. So, yung moist unit weight natin, kapag kinompute natin yan, makakakuha tayo ng 120.64 pounds per cubic foot. Lastly, sa ating saturated, dito, 0.42 yung kanyang moisture content, GS. Saturated natin is GS plus E unit weight of water over 1 plus E. Kaso, wala tayong E or void ratio. So, gamitin na rin natin si sewage SE WGS. However, sa degree of saturation natin na 100, so cancel na natin yan. So, E is WGS. So, pwede na natin din na i-direct sub. So, GS natin na 2.71 plus 2.71 plus i-sub natin 0.42 times GS na 2.71 overall 62.4 over 1 plus 0.42 2.71. So makakakuha tayo ng saturated unit weight na 112.303 pounds per cubic foot. So to summarize, unit weight of dried sand is 110.24, sorry, pounds per cubic foot. Moist naman, dito sa may capillary zone, meron tayong 120.64 pounds per cubic feet. And saturated, ito, 112.303 pounds per cubic foot. So, yun yung mga na-compute natin na mga unit weights. Okay? So, to answer the question, determine the effective stress at point B. So, dito daw. So, yung mangyayari dito is ito yung consider natin na soil, yung 6 feet. However, dahil nga meron tayong capillary rise, so ima-minus natin yung kanyang effect. Okay? So, letter A, what is the effective stress at point B? So, 6 feet or unit weight of sand natin is 110.24. 110.24 pounds per cubic feet multiply by yung kanyang depth na 6 feet minus yung effect ng capillary rise. So dahil capillary rise upward dyan, so negative and negative naman palagi. Degree of saturation is 50%. So kailangan in terms of decimal. So we have 50 divided by 100. Tapos 62.4 pounds per cubic foot multiply by yung kanyang depth na 3 feet. 3 feet. Kapag ko-compute natin yan, $110.24 times 6 minus negative 0.5 times 62.4 times 3, 755.04 pounds per cubic foot. So, makikita natin na by the capillary action, mas nadadagdagan pa yung stress or yung pressure na nakukuha or na-experience ng ating cell dahil binayos na natin yan, negative times negative, magre-result yan into a positive value. So, by this equation, yung total effective stress na sa point B is 755.04 pounds per cubic foot. Second, determine the effective stress at point C dito. So, dito, dried pa tayo dito. Due to the capillary action, moist yung ating soil sample. So, parang since nalagpasan na yung ating capillary zone, there's no need to consider pa yung kanyang capillary action or capillary rise. Okay? Next, effective stress at point C is 110.24 multiplied by 6 plus dito, yung moist tayo dito dahil meron siyang capillary action and nandito pa lang yung ating groundwater table. Okay? So, 120.64 multiplied by yung kanyang depth na 3 feet. And kung susumahin natin, yung effective stress is equal lang din pala siya or equal lang siya sa total point C. Anyway, so to solve that, 110.24 times 6 times 120.64 times 3 feet, makakakuha tayo ng 1,203.36 pounds per cubic foot. So double check, 110 times 24, so 110.24 times 6 plus 120.64 times 3, 1,023.36 pounds per cubic foot. Last question, letter C. Determine the effective stress at point D dito sa pinakailalim. Okay? To solve that, since effective stress na yung letter C natin dito, so dadagdagan na lang natin siya ng value na ito, effective stress. So effective stress at point D is effective stress at C. So kung gusto natin ulitin ito, okay lang. Pero since na-compute naman natin yan, consider na lang natin yung nakuha natin na value. Plus, saturated tayo 112.303, 112.303, meron yung depth na page 3 natin 6 feet din. Next, since effective stress yung pinapakompute and located na yan below the groundwater table, i-compute na natin or bawasan na natin yung value ng tubig or water pressure. So to do that, just subtract 9.81 multiplied by 6 feet kasi 6 feet yung thickness. Whereas yung effective stress natin is 123 or 1,023.36 pounds per cubic foot. So the effective stress at point D is equals to, kapag kinumpit natin yan, makakakuha tayo ng 1,638.32 pounds per cubic foot. So double check, 1,023.36 plus 112.303 times 6 minus 9.81 times 6. Sorry, meron tayong mali dito. Since English pala yung ginamit dito. So this is 62.4. 62.4. So mali yung sagot natin. So 1,023.36 plus 100.33 minus 62.4 times 6 feet, meron tayong value na 1,322.78 pounds per cubic feet. So, ganun ni-compute yung mga effective stresses natin. Okay? So, ganun lang pag-compute sa vertical stresses. Okay? So, to sum up, vertical stresses, na-compute natin kung paano ba compute yung total vertical stress natin, yung kabuuan. Yung pore water pressure naman, kung ano yung pressure na induce ng presence of water table. And the effective stress is the difference ng ating total vertical stress and pore water pressure or the neutral stress. Okay?